Welcome to an ASMR book tour of Modern School Solid Geometry. Let's begin. We have this wonderful green cloth cover printed with geometric solids on the front here. Here's our spine of the book. It's a fairly thin book, even as older textbooks go. We have something from one of the original users of the book, 1945. Though we see here that this copyright is 1939. I like that. The House of Applied Knowledge, established 1905. I think prefaces tell us things. Let's read this one. It is generally agreed that the primary purposes to be achieved through the study of solid geometry are 1. The discovery of geometrical truths of three-dimensional space and their establishment by logical methods. 2. The development of computational skill involving both arithmetic and literal numbers in the mensuration of common geometrical solids. 3. The practice of perceptual analysis leading to the ability to see relationships in space. And 4. An extension of understanding of the nature of logic. Obviously, a student cannot discover the truths of solid geometry or establish them by logic unless he analyzes the relationships of points, lines, and planes in space, and is responsive to the same niceties of logic that are exercised in plane geometry. The clear visualization of spatial relationships is essential as the basis of understanding the postulates and definitions of solid geometry. Accordingly, the authors have given careful attention to training the student in the analysis of three-dimensional space. A brief preliminary discussion of perspective is introduced in order to acquaint students with the representation of three-dimensional figures in a plane. For the development of computational skill, the authors have included a large number of carefully graded exercises involving both arithmetic and algebraic computations. Special features of the author's plane geometry textbook, Modern School Geometry, are continued in the present book. These include the following. Understandings are developed. The authors are in complete accord with the view that geometry should be understood rather than memorized for reproduction. Careful inductive developments of the concepts of solid geometry are a regular instructional technique. The student is consistently required to think through his work, to learn by his own activity. Students are led by easy steps to proofs in 3 dimensions instead of being required at the outset to study the difficult propositions ordinarily met at the beginning of the course. Reasoning is emphasized. The authors have recognized the fact that development in logical thinking is one of the main objectives of the teaching of demonstrative geometry, and consequently have kept the logical aspects of the course in the foreground. The student is led to appreciate the importance of definitions, assumptions, hypotheses, and conclusions. Both indirect and direct methods of proof are employed. Exercises, tests, reviews, etc. are provided. Developmental exercises precede a new topic or proposition and prepare for it. These exercises are intended for class discussion. Proficiency exercises are placed immediately after a topic or proposition that has been developed in order to give it added meaning through use. In addition to the developmental and the proficiency exercises, there are also provided chapter tests at the end of each chapter and review exercises at intervals throughout the book. The authors have likewise retained the Maintaining Skills pages, which proved so valuable a feature of the plane geometry. By means of these pages, the basic skills of arithmetic and algebra, which have been acquired in previous years, are kept alive in the student's mind. Interest features are provided. It is true that the primary interest in any class must be the intellectual one that arises from an understanding of the subject matter, but the authors have not on this account neglected to make the book as attractive as possible from other points of view. This arrangement of the pages in both type and illustration makes this textbook unusually inviting in appearance. The authors which wish to express their appreciation to the teachers of geometry who have used their earlier books and whose recommendations have proved valuable in the preparation of the present one. In particular, thanks are due to Leland W. Smith of Classical High School, Springfield, Massachusetts, for his careful reading of the proof and his numerous suggestions. Let's look at the table of contents. 1. An introductory chapter. 2. Perpendicular lines and planes. 3. Parallel lines and planes. 4. Dihedral and polyhedral angles. 5. Locus and projections. 6. Polyhedrons. 7. Cylinders and cones. 8. Spheres. 9. Spherical polygons, spherical volumes. A word to the student. To students who have asked what value the study of solid geometry would have for them, the authors have made this reply. The study of solid geometry will give you 1. Greater power in perceiving the relationships of objects in space. 2. Continued growth and power in logical reasoning. 3. An opportunity to put your arithmetic and your algebra to work for you. 4. Further understanding of the practical problems met by the architect, the engineer, the carpenter, and the mechanic. And 5. The pleasure which capable students of mathematics derive from successful intellectual inquiry. As promised, there's a test, and we're seeing attractive figures. I always like it when the students wrote in the book. See, this is part of why I do it. It's a reminder that this is something people have done for generations. This is an area formula. Not everyone learns. See, now I'm interested in whether that formula was in here. I don't see why it would be, actually. But this is Heron's formula, where it's the area is the square root of S times S minus A times S minus B times S minus C. And A, B, and C are just the sides of the triangle, the side lengths. And S is a calculated parameter, which is half the perimeter. So I don't know why the student wrote that right there. So there's the first test. Oh, interesting. Photograph of Park Avenue. Notice how the parallel lines seem to converge toward a point as they recede from the observer. It's worth pointing out that perspective developed as an artistic technique after the development of mathematical ideas that support it. This is actually really nice. I love that math connection to art. And obviously solid geometry is especially important for artists who wish to do realistic work. Some algebraic stuff. An oil refinery at Martinez, California. Problem solving helps. Another chapter test. The steeple of this church is in the form of a polyhedral angle. A trihedral angle. This is one of those old-fashioned math words that you don't see a lot in secondary education, at least in my experience. Locus is a Latin word meaning place. In plane geometry, a locus is usually a line or group of lines which contains all the points in a plane that satisfy a given condition and which contains no points that do not satisfy the condition. So in other words, if and only if the point satisfies the condition will it be in the locus. It's interesting asking kids to define circle. They don't usually come up with a mathematically rigorous definition right away. It's fun to guide them toward that. A circle is a locus of points which are a fixed distance from a certain point within a plane. Polyhedrons. If the following patterns are copied on cardboard, cut out, and folded along the dotted lines, they will form models of the 5 regular polyhedrons. Number of faces, edges, and vertices of the 5 regular polyhedrons. The Empire State Building. Cavalieri's principle. The accompanying illustration shows a stack of 100 square cards and a stack of 100 round cards. All the cards are equal in thickness. The bottom 2 cards are equal in area. The 2 cards next to the bottom are also equal in area, but are smaller than the bottom cards, etc., up to the top cards, which are also equal in area, but are the smallest. Any card in the first stack, therefore, is matched by a card in the second stack, the same height from the bottom and having the same area. The stacks, of course, are equal in volume. Now we may think of any 2 solids as made up of very, very thin horizontal slices corresponding to thin cards, and if every such slice in one is matched by a slice in the other having the same area, the solids are equal in volume. The 2 solids in the accompanying figure, called a pyramid and a cone, have bases of equal areas, and sections at equal heights from the bases are likewise equal in area. Comparing areas of sections is like comparing areas of corresponding slices. Hence we may assume the following principle, a more complete proof of which is given in higher mathematics. Postulate. If two solids have equal altitudes, and if sections formed by planes parallel to the bases and at equal distances from the bases have equal areas, the solids are equal in volume. This proposition is known as Cavalieri's principle after the Italian mathematician Bonaventura Cavalieri, 1598 to 1647, who first discovered it. This principle is one of the ideas that gets expanded upon in calculus somewhat, and I think that's the higher math they must be talking about, because it's certainly used in calculus. I'd like to flip quickly through the rest of this, see what else we find might be interesting. Spheres. The Earth as a sphere. Early measurement of the Earth. Spherical triangles, which if you get into this, you'll find out that the sum of the interior angles do not equal 180 degrees. A lot of surface things, spherical excess. This is the kind of thing you don't really learn in high school anymore. So don't ever believe people that say that education hasn't changed. The math is the same for the most part, but we certainly learn it differently and at different times. And if you've noticed that books from this period, like this one, use male pronouns, well, we also have better ideas now about who does math. Though, of course, women did math back then, otherwise who would have been the women who became computers and pioneered the field of computer programming? So even though the books were written in a way with the idea that only boys were doing this, we know that's not the case. Certainly some girls and women did. Hopefully that was interesting. Take care now.